Hello, you're very welcome to this video on the method of Gaussian elimination. I'm Seamus Ballew, and this video is for second year electronics students at Dundalk Institute of Technology. Gaussian elimination is an important mathematical technique for solving systems of equations that arise in an electronic context. For example, Kirchhoff's law or in linear circuit analysis. So we'll make a start. So we're going to use matrices to solve systems of equations. Now here's a simple example of an equation that you'd have solved in school. It's a 2 by 2 system. X plus 5y equals 13, x plus 8y equals 19. And you could nearly see the answer to that question there. So there's the answer there. X is equal to 3, y is equal to 2. And you can check that very easily. 3 plus 5 2's, 3 plus 10 is 13. And then in the second equation, 3 plus 8 2's, that's 3 plus 16 is 19. So we already know the answer to this system of equations. We already know the answer to that system of equations. So really what we're interested in is the process of how to solve these equations using Gaussian elimination. And then we'll solve 3 by 3 systems that are a little bit more complex. And the method can be used to solve larger systems. Now, likewise, in an electronic context, instead of x and y, we might have maybe an example of Kirchhoff's law or a particular circuit where we've got I1 plus 5I2 equals 13, I1 plus 8I2 equals 19. And again, I1 would be equal to 3, I2 would be equal to 2. In matrix form, if we take this system of equations, we're going to be using matrices, so we want to put it into matrix form. So that's how it would look in matrix form. And just to check out, do you remember when we were multiplying matrices, you'd do row 1 by column 1. So row 1 by column 1 would be 1 times x plus 5 times y. And that gives you what's there on the left hand side, and that's equal to 13. And then for the second equation, you could do row 2 by column 1. And that's equal to 19 on the right hand side. So that system of equations can be written in matrix form. And then likewise, if you're using the current notation I1, I2, that would be how we could write it in matrix form. So basically, you just lift off the numbers in front, those numbers in front of the coefficients of the x's are 1. So it's 1, 1, 5, 8. That gives you the matrix times xy equals, and on the other side then we have the numbers 13 and 19. So we'll make a start on the Gaussian elimination. So we want to solve this system of equations. It's the same system. We know the answer. X plus 5y is 13. X plus 8y equals 19, or in the I1, I2 form as well. So for the Gaussian elimination, what we're going to do is we're going to take the 1, 1, 5, 8, and we put it into a matrix on the left-hand side, and then we have a line down the middle, and then on the other side we have the 13 and the 19. So the line down the middle kind of represents the equal sign. This is what we call an augmented matrix. And that's just another way of representing what we had in the previous slide. You multiply the matrix by xy equals 13 by 9. But for the Gaussian elimination, we'll use this augmented matrix form. So how does the process of Gaussian elimination work? Well, we concentrate on this matrix here on the left-hand side. And we're interested in changing it into the form of 1, 1, 0. Do you remember we were talking about the identity matrix? The identity matrix is 1, 0, 0, 1. So this Gaussian elimination is a bit like that. We're interested in getting ones on the diagonal and then zeros below the diagonal. And we always aim for this. It will be the same process every time. So this particular example, we're using a 2 by 2 example. And it's kind of helpful that you know the answer. So we're always going to aim to get 1 along the diagonals and 0 below the diagonal. Now, the other numbers are going to change in the process, but we always aim to get 1, 1, 0. So how do we get a 1? And very simply, we get a 1 by dividing the row across by the leading number. So supposing that number had been a 2, all we do is we would divide the whole row across by 2. And you know you can do that in an equation. You can divide both sides of an equation by the same number. But in this particular case, the number is already 1, so we won't have to do that for a start anyways. And how do we get a 0? We get a 0 by either adding or taking away pivot rows. So we regard that as a pivot row. There's a 1 on it. So you'll see how the process works in a minute now. Okay, so we'll make a start. Here's our equation. We put it into augmented matrix form, and we're aiming to get 1, 1, 0. So we already have that 1 there, so that's done. So the next task is to get the 0 in that position. And how do we get the 0 in that position? So we'll start on the first column there. We won't worry about the second column for a minute. We tend to stay on the first column to get the 1 and the 0s underneath it. So we aim to get the 0, and all we do is, in this case, it's row 2, and all you do is you say row 2 minus row 1, and you work your way across as we do that. So it's row 2 minus row 1. We just indicate what we're doing. So we write row 2 minus row 1 after the matrix. So very simply, what happens if we do row 2 minus row 1? So it's 1 minus 1 gives 0. 8 minus 5 gives 3. 19 minus 13 gives 6. So they'll be the new numbers along there now. So it'll be 0, 3, 6. So if we move on to the next slide, and we'll see that. So again, just to highlight, so the 0 moves down to that position, 3 moves down to that position, and the 6 moves down to that position. So taking away that detail, you can very simply see now what you simply do to do row 2 minus row 1. 1 minus 1 gives 0. 8 minus 5 is 3. 19 minus 13 is 6. So that's where we're at now. So we've achieved the 1 and the 0. And the last thing we want to do is to get a 1 in that position. And how do we get a 1 in the position? And you might remember earlier on we said if you want to get a 1, you tend to divide across the row by the leading number. So what's the leading number in this row? That's a 0, so that's kind of sorted out. So the leading number is 3. So all we're simply going to do is we're going to get row 2 divided by 3. Let's have a look at that. So we just write down that we're going to do row 2 divided by 3. So what happens when we do row 2 divided by 3? So 0 divided by 3 is 0. 3 divided by 3 is 1. 6 divided by 3 is 2. And suddenly we have our system now in the form that we wanted it in. And it'll make it easy now to solve the system of equations. So if we move on to the next slide. So remember, we started with this system of equations and we fed it into this augmented matrix form. Now that we've got to this situation, what we're going to do is we're going to extract out the equivalent equations. And you might notice the first row hasn't actually changed. So that first equation is still going to be x plus 5y equals 13. But what's the second equation going to be? It's going to be 1y equals 2, or just simply y equals 2. So x plus 5y is 13, y equals 2. Now that we know that y is equal to 2, all we do is we substitute y back in for y in the first equation. So x plus 5 times 2 equals 13, x plus 10 equals 13, x equals 3. So now we have our answer. X is 3, y is 2. So that's the answer to that system of equations. And we got that by using Gaussian elimination. So you can just write out your answer finally then. X is 3, y is 2. Or if we've been using the I1, I2 notation, I1 is 3, I2 is 2. And we have already checked that they're the correct answers. So then that's how the whole slide would have worked. You'd have sort of seen what we did. So again, to summarize, we did row 2 minus row 1, and that gave us that augmented matrix. And then the next step was to divide across by 3, and we got that form, and we extracted out our matrix. You'll get used to the process. So we're going to concentrate on 3 by 3 examples, but let's just do one more 2 by 2 example just to get a little bit more confidence in it. So here's our equation. 2x plus 6y is 24. 5x plus 11y is 46. Again, we're aiming for this situation here. Now, what do you notice this time? We don't have a 1 this time, so that's our first step. We're going to concentrate on this column here. We're going to try and get that 1 first, and then get a 0. So how do we get a 2? All we do is we go row 1, divide across by 2. If that number was a 7, we divide by 7, and so on. So what's row 2 divided by 2? it'll be 1, 3, 12. So that's our first step. So 1, 3, 12, and we still have the same row 2, 5, 11, 46. So the next step then is to get that 0. So how do we get a 0 in that position there? So when you want to get a 0, it's always rows take away rows. So in this particular example, it'll be row 2 minus how many row 1s? Well, if that leading number is 5, then it'll be minus 5 row 2. If that leading number had been a 7, we'd say row 2 minus 7 row 2, and so on. So here we've decided to go row 2 minus 5 row 1. So 5 minus 5 is 0, and it'll be 11 minus 5 threes. 11 minus 5 threes is 11 minus 15, which is minus 4. So minus 4 goes into that position. And then what do we do with 46? It's 46 minus 5 12s. 46 minus 5 12s is 46 minus 60 equals minus 14. That's our new row 2. Now, is that system in that form there? It's not quite. It's getting there. So the last thing we want to do is try to get that to be a 1. And remember, how do we get a 1 to be in the position where we want it? So remember, you divide across the row by the leading number. So when you're looking for 1s, you tend to divide by the leading number. When you're looking for 0s, it's row minus another row. For that example there, it was row 2 minus 5 row 2s. So when it's 0, you're taking away rows or adding rows. When you're looking for a 1, you just divide by the leading number. So here we'll be dividing by minus 4. Dividing by minus 4. So minus 4 divided by 4 is 1. Minus 14 divided by minus 4 is 3.5, 3.5. And of course, 0 divided by any number is still 0. So now we've got our system in the form that we want it in. And we can now just read off the equations. So again, you feed the equation into the augmented matrix. And now that we've got our matrix in the form that we wanted, using Gaussian elimination, we can extract out the equivalent augmented matrix. So what does the system look like? So basically it's x plus 3y equals 12 and y equals 3.5, or technically it's 1y equals 3.5. And then to work out the x value, you just feed 3.5 back in for y. So x plus 3 times 3.5 equals 12, and that's 10.5. So x is equal to 12 minus 10.5, x equals 1. And you can check your answer. So how do we check our answer? We just fill the x and y numbers back in here and see how we get on. And you can see there in the first one, it's 2 times 1.5, which is 3. 6 times 3.5, which is 21. 3 and 21 is equal to 24. And likewise for the second equation. So we've solved that system using Gaussian elimination. So now, example 3. Using Gaussian elimination, solve the system of equations. X plus 3y plus 11z is equal to 169. And likewise, x plus 4y plus 15z is 228. 2x plus 8y plus 20z equals 326. These numbers are slightly large, but they're the kinds of numbers you might encounter when you're working with Kirchhoff's equations. And then obviously in the I1, I2, I3 form. So they're the same equations, only instead of x, y, and z, we've got I1, I2, I3. But we'll concentrate on the x, y, and z form. So this is what we call a 3x3 system, and this time we're going to aim to get the system in this form. So again, it's 1, 1, 1 along the diagonal and zeros underneath. So putting the system in augmented matrix form, that's a 1 in front of that x, that's a 1 in front of that x. So basically it's 1, 1, 2 in the first column, 3, 4, 8, 3, 4, 8, 11, 15, 20, 11, 15, 20, and then you have the numbers on the right hand side. So how do we get the zeros? Now, well, we want to get a 1 in that position there. We already have the 1, so that's done. So now we're going to concentrate on those two zeros. So just to show you that then. So we're concentrating on that column of numbers first. So we've the 1 done, and now we're going to look at the two zeros. And then when we've that done, we'll try and get the 1 and the 0 into that position. So let's make a start then. So what we're going to do is we're going to do row 2 minus row 1. That'll be 1 minus 1. And then we'll do row 3 minus 2 row 1. So you'll see how it works now as we proceed on. So let's just concentrate on the row 2 for a minute. we want to try and get the row 2 to look like this, that it's 0, 0 in the leading position there. So basically we just simply do 1 minus 1. So it's row 2 minus row 1. So 1 minus 1 gives 0. 4 minus 3 equals 1. 15 minus 11 equals 4. 228 minus 169 is equal to 59. So these are the new numbers now for row 2. They'll be the new numbers that will go underneath there in row 2. Okay, so we've done row 2 minus row 1. And now we proceed on then. We want to sort out row 3. So we've got that 0 in place now. So how do we get this 0? So what's the leading number this time? The leading number is 2. So that tells us how many row 1s we want to take away. So it's row 3 minus 2 row 1. So if that had been a 7, we would have said row 3 minus 7 row 1. So we're doing row 3 minus 2 row 1. And let's have a look at that. So I've taken away row 2 there for the moment. So we're concentrating on row 3. So it's row 3, take away 2 row 1. So it's 2 minus 2 1s gives 0. That's what we want. 8 minus 2 3s is 2. 20 minus 2 11s is minus 2. So that's what we went into that position there. And then it's 326 minus 2 169s. And that gives us minus 12. So the new numbers for row 3 will now be 0, 2, minus 2, and 12. So you can see we just slot them in there into that position. So we've simply done row 3 minus 2 row 1. 8 minus 2 3s gave 2. 20 minus 2 11s gave minus 2. And 326 minus 269s gave minus 12. And there's the details on the calculations. So we've now got this much of we're aiming to get this. We're doing the Gaussian elimination, and this is the way we want the system to look in the end. So with the first column sorted out. So the next column now to sort out will be to get that 1 in its position. And you kind of notice we already have the 1 in that position. So that bit will be done. So we just need to look at the 0. These are always done in a certain order. Aim to get that 1 first. Then when that 1 is sorted out, you do the 2 zeros underneath. Then you go on to the second column. You aim to get that 1. Once you have that done, you aim to get that 0. And then finally, you aim to get the 1 on the third column. So, again, we've just sorted out the 1 and the 2 zeros. And now we have that 1 sorted out. That one there. So this 0 is our next task that we want to achieve. Okay, so we're on row 3 and we want to get this 0 in position. So the leading number is 2, and when you want to get a 0, you always take away rows. Now, when we were doing these positions, we went back to row 1, but now that we're at the second column, we won't go back to row 1 because those zeros are sorted, and that's a 1, that's a pivot. So these are relative to each other. 0 minus 0 won't interfere with, won't change. So we simply say row 3 minus 2 row 2. So that 2 is deciding that 2. If that was a 6, we would have said row 3 minus 6 row 2, and so on. So we're doing row 3 minus 2 row 1. So how does that look? It's 2 minus 2 1s. Minus 2 minus 2 4s gives us minus 10. Minus 12 minus 2 59s gives us minus 130. So that row 3 will now look like those numbers. And there's the details. So it's looking like 0, 0, minus 10, minus 130. Obviously, we didn't do 0 minus 0. That was already going to be obvious. Okay, so we're getting near the finishing line. We just need to get that 1 in position. So how do we get the 1 in position? When you're looking for a 1, you divide by the leading number. So it'll be row 3 divided by minus 10. And that gives us 0, 0, minus 10 divided by minus 10 is 1. Minus 130 divided by 10 is 13. So now we have our system, our augmented matrix system. After doing the Gaussian elimination, we have it in this form here. And we can now read off our answer. So again, do you remember we fed these equations into the augmented matrix form? Now we're going to extract out our new equations, even though the first equation hasn't changed. First equation would still be x plus 3y plus 11z equals 169. The second equation is y plus 4z, there's no x term, y plus 4z equals 59, and then it's z or 1z equals 13. The idea of the Gaussian elimination is that you end up with one of the variables that you're looking for, and then you can feed it back in to work out the other ones. So z is equal to 13. Then we use the second equation to find out y. So y plus, and feed the 13 in for z, substitute it in. 4 13s are 52. Y plus 52 equals 59. So therefore y equals 7. And then you feed back into the first equation to get x. X plus 3y plus 11z is 169. X plus 3, but y is 7, so substitute 7 in for y. 3 7s are 21, plus 11 times 13. 11 times 13 is 143, and 21 and 143 is 164. So x plus 164 equals 169, so x is equal to 5. So now we've solved our system. X equals 5, y equals 7, z equals 13. And we can do a little check on that. So taking our x, y, and z, so you can substitute the 5 in for x, the 7 for y, and the 13 for z, and multiply it out. And in that first example, it's 5 plus 21 plus 143 is indeed equal to 169. And similarly for the other ones, x plus 4 7s plus 15 11s, that's 5 plus 28 plus 195, and it is equal to 228. And then the last one, 2x, 2 5s are 10, plus 8 7s are 56, plus 20 13s, 260, add them all up, and we get 326. And again, that's the correct answer. That 59 there is only a typo. You can ignore that. Okay, so moving on to example 4. So you kind of know how the method works now. So this is just kind of a reinforcement example. So again, we have system of equations, 3 by 3 system. X plus 5y plus 13z is 55. 3x plus 17y plus 9z is 79. 7x plus 40y plus 21z equals 185. So we put this system of equations into augmented matrix form. So 1, 3, 7 are the numbers in the first column, 5, 17, 40 in the second, 13, 9, 21 on the third column, 55, 79, 185. That's plus 21. That plus sign is not great, but you can kind of see it. So it's plus 21. And again, the aim of the exercise is to get this augmented matrix here, get it in that form. So again, we're going to concentrate on that first column of numbers. We have the leading one already, so that's done. Now we want to get zeros in those two positions. And to get zeros, we do rows minus row 1 in this case. So it'll be row 2 minus 3 row 1. So the leading number 3, that's why we do minus 3 row 1. Whereas in the row 3, it's row 3 minus 7 row 1. Those numbers just simply decide how many row 1s you take away. So, looking at the process then, what happens when we do row 2? So, row 2 minus 3 row 1, that's going to give you 0 in the first term. Then it's 17 minus 3 5s, gives us 2. 9 minus 3 13s, which is 9 minus 39, which is minus 30. 79 minus 3 55s. 79 minus 3 55s, that's 79 minus 165 is equal to minus 86. I know these numbers are large, but sometimes it's kind of good just to see large numbers. It just kind of nearly makes it clearer what's happening. So the 4 new numbers now for row 2 after that process will be 0, 2, minus 30, and minus 86. So we'll have generated that 0 there. So that's the row 2 sorted out. And now we're going to sort out row 3. So there's the row 3 at the moment. So I'll just hide row 2 for the moment. It allows us to concentrate on row 3. So there's the row 3, and we want to do row 3 minus 7 row 1. So 7 minus 7 1s is 0. 40 minus 7 5s. 40 minus 35 is 5. 21 minus 3 13s. Sorry, minus 7. I might have said 3 there. 40 minus 7 5s is 35. 21 minus 7 13s. 21 minus 91 is minus 70. 185 minus 7 times 55, which is 185 minus 385, which is minus 200. So our new numbers now for row 3 will look like 0, 5, minus 70, minus 200. So there are the numbers there in row 3, and then bringing it all together, we end up with this situation. So we did row 2 minus 3 row 1, that gave us that new form there, and then we did row 3 minus 7 row 1, and that gave us that form. So suddenly with the 1 and the 2 zeros, there's the 1 and the 2 zeros. So we have that bit of our system sorted out. So looking at this scheme then, next thing we want to do is to get that 1. So looking at that there, so in that situation there, it's a 2, so it's not quite a 1. So what do? When we're looking for a 1, we divide by the leading number, divide the row by the leading number. So this will be row 2 divided by that 2 there. If that had been a 6, it would be row 2 divided by 6. But here it's row 2 divided by 2. So row 2 divided by 2 gives us 0, 1, minus 15, minus 86 divided by 2 is minus 43, and we didn't change row 3 in the process. So now we have that 1 in place, and our next task is to get that 0. And like the previous example, we're going to involve row 3 and row 2. So it's going to be row 3, take away how many row 2s? So you just look at the leading number. It'll be row 3 minus 5 row 2. Whatever number is there. So this process is always the same. Follow the steps. So what does row 3 minus 5 row 2 look like? That's row 3 minus 5 row 2. Well, obviously 5 minus 5 once just gives you 0. I didn't write that down. 0 minus 0 is still 0. So they'll give you 2 zeros in those positions. Then it's minus 70 minus 5 by minus 15. So it's minus 70 minus 5 by minus 15, which is minus 70 plus 75. That's going to give us 5. Minus 200 minus 5 times minus 43. And that's 200 minus, it's minus 200 plus 215. Minus 5 by minus 43 is plus 215. So we end up with 5 and 15 for these two figures here, and that has become a 0. So that's how we're looking now. So we're nearly there, and the final thing to do is to get a 1 in that position there. So basically it's row 3 divided by 5. And that gives us 0, 0, 1, 3, and now we have, after the Gaussian elimination on the original augmented matrix, we end up with this form, and that matches that there. And all the other numbers in the original matrix have changed as the process went on. But now we can extract out our equivalent equations, and we can get our solutions for x, y, and z. So z is equal to 3, y minus 15z equals minus 43, x plus 5y plus 13z equals 55. So we know what z is, so you're kind of back substituting, that's what you're doing. So you can extract out your equations, you know what z is from the bottom row, and then you feed back to get y. So y minus 15 by 3 equals minus 43, y minus 45 equals minus 43, so y equals 2. And then in the top equation, x plus 5y plus 13z equals 55. So you're substituting in 2 for y and 3 for z. So it's x plus 5 by 2 plus 13 by 3 equals 55. So that's x plus 5 2s are 10, and 3 by 13 is 39. So 10 and 39 is 49. So x plus 49 is equal to 55. So x is equal to 6. So just writing those answers out then. X is 6, y is 2, z is 3. And they're the answers to the system of equations. And you can do a check on your answer again. You could fill 6, 2, 3 in for x, y, and z as you go across there. So let's just check that last equation there. So 7 by 6 is 42. 40 by 2 is 80, 21 by 3 is 63, 42 and 80 and 63 is indeed equal to 185, and as we say, you can check the other two equations. So you got the answer now to that system of equations. So we hope you've enjoyed this video on Gaussian elimination, and you might be able to have a chance now to have a go at some of the exercises that are up in Moodle. So until the next time, thank you very much.